Hello viewers, welcome back to class. I'm super excited to welcome you guys back to class again. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure you turn on the post notification bell for more exciting videos. Guys, I'm super excited how far we have gone in this lesson. Let me quickly remind you guys, do not skip any part of this video for your own good. And ensure that anytime you are set to watch and to learn new concepts from Master Builders Online Academy, do not welcome any form of distraction. And finally, if there be any part in this video you do not understand, when you watch it for the very first time, guys, you have the singular opportunity to replay the video over and over again until you understand it. And yes, you can understand it if you pay close attention. Then finally, if there be any part you do not understand after watching the video over and over again, then you can quickly go to the comment section and document your questions. Will we attend to your questions to your satisfaction? If this is taken, let's get to the business of the day. Now on the board we have differentiation, integration of functions. And now we are currently in definite integrals. Definite integral. Definite integrals. Now, definite integrals are not different from the normal integration problems we have solved earlier. Definite integral, this is when the value of the integration function is obtained in values, not in variables, not alphanumerical functions, but in values. So in this case, for definite integrals, what happens is that you are given the upper limit and the lower limit. Now, if y is equal to integral of any function, this is the upper limit, x2, this is the lower limit, x1. Lower limit, upper limit. So anytime the upper limit and the lower limit of any integral is given, then you are dealing with definite integral. And it is still under this definite integral that we look at area under curve. So in this aspect, the question can either come as an integral with definite value to integrate any function and then substitute, or you are asked to find the area of the curve under the following given functions. So now, understand that for any integral that has upper limit and lower limit given, you are dealing with definite integral. And in such integral, you have definite values. You can have 10, you can have 4, you can have 5, you can have positive of those values, depending on the function that you have. But it must not contain a variable. The final answer shouldn't contain variable, because this upper limit and the lower limit are the values you will substitute for x. And now, how do you make use of these two values? First, before you can substitute in the upper limit and the lower limit of any given function, you must first of all integrate that function. And understand that this f of x here can be any function. It can be a linear function, it can be polynomial function, it can be trig function, it can be exponential function, it can be any function that we have treated earlier. It can be any function. So all you need to do is to first integrate the function, then substitute the value of the upper limit and the lower limit. So the first thing you do is to put in the value of the upper limit into the resulting value you have after you have integrated the given function and get the result, then minus put in the value of the lower limit. So you substitute the upper limit first, minus substitute in the lower limit. And that's exactly what we have here, area under curve for definite integral. So if this is y is equal to this function of x, this is the upper limit, this is the lower limit. So what you do is to integrate this function. After you have successfully integrated this function, any type of function that you have, after you have successfully integrate the given function, then substitute the upper limit to that function and get the result, minus substitute the lower limit and get the result. Whatever you have, becomes the final answer. Now, if this is understood, let's solve the problems that we have before us. Now, we are asked to find the following definite integrals. Alright? Now, we have number one on the board. Question number one. Y is equal to integral 3 to 8 x cubed all dx. So the first thing you do now is to identify the function here. The function here is a polynomial function, and you know how to integrate polynomial functions by increasing the power and now divide the whole function by the new power. Then this would have given us 8x raised to the power of 4. We just increase the power by 1, then divided by 4. Pull down the upper limit and the lower limit. Here, there is no need for you to introduce the constant, because at the end, the constant will cancel out. Alright? There is no need to put in the constant. Okay? So if this is understood, then 4 goes into this guy. We are going to have this as 2x raised to the power of 4. Then 3 to 2. So the first thing we will do is that we will substitute 3 in place of x. We have this as 2 into 3 raised to the power of 4. We just replace, this is this 2, x is replaced by 3, then the power remains the same, then minus, put down the 2 into, the power of x is 2, and the power of x is 4. This is it. So this would have given us 2 into 3 raised to the power of 4 is 3 times 3 times 3 in 4 places. And 3 multiplied itself in 4 places will have given us 81. 81 minus 2 into 2 raised to the power of 4 is 2 multiplied itself 4 consecutive times. And this will have given us 16. Now, finally, at this point, when we multiply 81 by 2, we have 162. And when we multiply 16 by 2, we have 32. All we just need to do is to remove 32 from 162. And whatever we have becomes the answer. This is the answer. If there is unit, then to the unit. Or if this is area bounded by square, you will have unit squared. Alright? So this is the value we have here for this question. This is it. Now let's look at question number 2 very, very quickly. Question number 2, we have that y is equal to integral of 1 plus x squared all dx. And this is 6, while this guy is 1. So first, we integrate this function. And when we integrate 1 with respect to x, we have x. When we integrate x raised to the power of 1 with respect to x, we have x squared over 2. And when we integrate s squared raised to s squared with respect to x, we have s cubed over 3. Then place your upper limit and the lower limit. At this point, now that we have successfully differentiated and nothing can cancel out, then we will have to substitute in the upper limit. Of course, we know that this aspect, your calculator can work this out for you. You that you are doing objective. Alright? Your calculator can work it out for you for objective purpose. Now, we have that 1 is equal to, put in the upper limit here is 6. So first of all, substitute in the upper limit in this whole function. So here we'll put in 6 plus 6 squared over 2 plus 6 cubed over 3. Then minus, we will now put in the lower limit. Then we have 1 plus 1 squared over 2 plus 1 cubed over 3. This is it. So first is to substitute the upper limit minus substitute in the lower limit. Now at this point, This will give us 6 plus 6 squared is 6 multiplied by 6, which would have given us 36 over 2. Plus you can short this, you can include everything here in your scientific calculator and have the answer directly. Okay? Now, 6, this is 36 multiplied by 6. There's 36. Carry 3. This time this is 18. 216. So this will have given us 216. 6 raised to the power of 3 is 216 divided by 3. Then minus 1 plus 1 over 2 plus 1 over 3. Now let's work on this bracket. This will have given us 6. 36 divided by 2 would have given us 18. And 216 is divisible by 3. So 3 into 21 would have given us 7. And 3 into 6 would have given us 2. Then minus. Now here we cannot add it. So what we need to do is to find the LCM of the denominator. And the LCM of 2, 3, and 1 is 6. So put down 6 and multiply 1 by 6. Then divide 6 by 2, multiply it by 1, which will have given us 3. Divide 6 by 3, which will give us 2. 2 multiplied by 1. This is this. So if you are not good with fraction, just check our playlist and look out for fraction in our playlist. You will learn a lot from that session. Now, we can boldly add all of these guys together. 18 plus 72 would have given us 90. And 90 plus 6, this would have given us 96. Then minus, when we add 3 to 6, we have 9. And when we add 2 to 9, we have 11 over 6. All we need to do is to find LCM of 6 and 1. And that would have given us 6. Now, 6 divided by 1 is 6. And so we have 576 minus 11. And when we remove this from this guy, we have 565 over 6. 94, whole number 1 over 6. 6 will go into 565 94 times. And 6 times 94 would have given us 564. When we remove 564 from this, we have a remainder of 1. So this is the answer to this question. Now guys, let's look at question number 3 very quickly. Question 3, we have y equal to integral of 2 to 1, 1 plus 2x exponent 3 dx. So now we have integration of linear function at this point. And now to integrate the linear function, first is to identify the power, and second is to identify the function of x. And now, when we integrate this function, we have 1 is equal to, the power here is 3. So we add 1 to this, it becomes 4. Then the function of x is 1 plus 2x. 1 plus 2x. And when we differentiate 1 plus 2x, we have 2. So we multiply these 2x. 4 multiplied by 2, we have 8. So we have 1 over 8 into. When we integrate this, we will have this as 1 plus 2x raised to the power of 4, or a 2 to 1. These are the upper limits. Don't forget, this is how we integrate linear functions. Identify the power, increase the power by 1, identify the function of x, differentiate and multiply the outcome, then take 1 over whatever you have as their product. Then repeat the equation and increase the power by 1. This is our limit. So all we need to do now is to first impute the upper limit, and this will have given us 1 over 8 into 1 plus 2 multiplied by 2 raised to the power of 4. Then minus 1 plus 2 into 1 all raised to the power of 4. Then we can close the bracket. First, we substitute the upper limit 2 in place of x. Second, we substitute the lower limit in place of x. Now we can simplify. This is 1 over 8. Now, 2 multiplied by 2 is 4, and 4 plus 1 is 5. So giving us 5 raised to the power of 4. Minus 2 multiplied by 1 is 2, and 2 plus 1 is 3. And this would have given us 3 raised to the power of 4. This is it. So we can use difference of 2 squares here. Can decide to read this like this. So now let's solve it out. This is 1 over 8. Now 5 raised to the power of 4 is 5 multiplied by 5, multiplied by 5, multiplied by 5. And this will give us 625. And 3 raised to the power of 4 is 3 multiplied by 3 in 4 places. Then we have this as 81. Now we have 1 over 8. When we remove 81 from 625, multiply by 544. And this is 544 over 8. We have 68. This is the answer to this definite integral. Then finally, now we have question number 4 on the board. Question number 4. Integrate y equal to integral of pi over 2 to 0 cos x dx. So first is to identify the function. This is a trig function. So when we integrate cos x, we have sine x. Then put down the upper limit and the lower limit. Now we understand that these values here are the values of x. And for trig identity, x is the angle. So now, when the value of x is in angle, is different from when you have a polynomial function. So therefore, anytime the value of x is in pi and the x is an angle, you must convert to a degree. Angle in degree, and we understand that in trigonometry that pi over 2 is the same thing as 180 degree over 2. Pi is equivalent to 180 in trigonometry, and it is 22 over 7 in geometry. So in trigonometry we have 180 over 7, but in geometry it is 22 over 7. Now this will have given us 90 degrees. So we can liken this to the what? Sine x of 90 degrees, 0 degrees. So understand that anytime you are substituting for trig identity and you are replacing the angle, you need to convert this angle to what? Angle in degrees. Now that we have converted the angle to angle in degrees, then we have y is equal to sine 90 degrees minus sine 0. First is to put in the upper limit, then we put in the lower limit. Now, this gives us sine 90 degrees is 1 and sine 0 is 0. So when we remove 0 from 1, therefore, the definite integral answer to this is 1. So we can also have this to be the area under the curve. And when we have area under the curve, like I said earlier, you will have a unit square. If this is area under the curve. Now that principles makes you principal. And when you understand boundary conditions, you will not overstep your boundaries. So the last but not the least is question number 5. 5. Y is equal to integral of pi over 2, 0, x plus sine x dx. So all we need to do now is to check this function that we have here is a function of linear and trig. And we have to integrate this differently from this. So I will integrate x and integrate sine x. I will integrate x and equally integrate sine x with respect to x. Now when we do this, When we integrate x, we have x squared over 2. And when we integrate sine x, we have negative cos x. So this will have changed to what? Minus cos x. This will have given us pi over 2, 0. And we already know that pi over 2 is the same thing as 180 divided by 2, which is 90 degrees. So we will now substitute. And now at this point, all we need to do is to substitute the value of x, which are the upper limits and the lower limits. So first, when we substitute the upper limit, we have pi over 2 squared all over 2 minus cos pi over 2. Then minus open bracket 0 square over 2 minus cos 0. Okay, now at this point, this would have given us pi square would have given us square over, when you square 2, you have 4, and 4 multiplied by 2, this would have given us 8 minus. Now understand that I explained earlier that when you have pi in front of a trig identity, that pi must be taken as 180 degrees. Unlike this now, this is just a geometry, but for this is trig. So for trig, you must always take pi as 180. So this will have given us 180 divided by 2, and this is cos 90 degrees, minus 0 of this is 0, and this will have given us plus, minus times minus. Now cos 0 is 1. Don't forget, cos 0 is 1, minus times minus is plus. Now this will give us y squared. Y is equal to pi squared over 8. Now what is cos 90? Cos 90 degree is 0 minus 0 plus 1. Then finally our answer becomes pi squared over 8 plus 1. This is your answer to this question. When you simplify this further, you will have 2.235 in decimals. So input this in your calculator, you will have this as your final answer. Or simply replace pi squared by 22 squared over 7 squared. This is it. So you will get this. Now guys, if you are yet to subscribe to this YouTube channel, do consider subscribing to our YouTube channel and ensure that you turn on the post notification bell for more exciting videos when uploaded. Guys, I know you will not like to miss out in the next lesson, so kindly check the description below where you will find the link to the next lesson. And if the next lesson is not yet there, then turn on the post notification bell so that when we upload the next lesson, you will be notified. So guys, don't forget to share this video, like this video, and make your necessary comments. I would love to see you in the next lesson. Thank you. See you guys in